Number 8 is a hard question. There's a lot of information in it, and it took me a couple times reading through it, writing out what I knew before I realized the best path to go forward. So this is an old AP question, so it shouldn't be a surprise that sometimes they give you difficult ones. But the first thing I had just written out was the probability that detector A goes off and detector B does not go off. So I just use B prime for B not going off. So I know this and probability was 0.25. It says the probability of A not going off is 0.35, which means the probability that A does go off is 0.65, just because they're complementary events. And I want to find the probability that B goes off. So I was looking at this, I tried playing with some formulas, and it didn't take me very far. So then I realized if I made a tree diagram, it would make my thoughts a little more organized, which is what helped me. So I'm not thinking of this as first A goes off and then B goes off, but remember, if you travel down this path, it is representing A and B. It is the product of A times B given A went off. So I went ahead and thought of it in this light so that I could go ahead and label 35% of the time, if there's motion, A won't go off. But that means 65% of the time it does go off. And then the only other bit of information it gave us was that A and not B is 0.25, which is telling me that this path, that product of A times not B given A is, what did it say? 0.25. Well, I know the probability of A, so I'm just going to get rid of that. I know that that's 0.65. So I can solve for what's missing on that branch denoted with that equation, with that symbolism. I could divide those two. 0.25 divided by 0.65. It's a non-terminating, maybe I should use a fraction. 5 out of 13. That way I'm not rounding. So I know that there's a 5 in 13 chance of this branch happening, which leaves me 8 out of 13 for this branch. The only other thing that's left is the other branch over here of A not going off, and then what happens for this. So I want to point out that it does tell us that, where is it? One or both always go off if there's motion, which means it is not possible for A prime to happen and then B prime to happen. It says that that never happens. One of them always goes off. So I know this happens 0% of the time, so that leaves this to happen 100% of the time. So a really complicated way to fill out this entire table, but now we're left with finding the probability of B. And I'll point out there's two ways that B could end up happening. B can go off and A, so I'm going to find the probability of A and B, or the probability that A didn't go off and B does. So this just turns into the product of this branch, so 0.65 times that 8/13, plus the product of this branch, which is 0.35 times 1. So when I multiply those together, I get 0.75, which is why the answer should have been E. But if you struggled with that, I totally get why. There's a lot going on.